In this video, I'll show you how to find the domain and range of functions. This is part 2 in the series. The first question reads, find the domain and range of y is equal to the square root of x minus 7. When determining the domain, we want to find all of the values of x for which the function is not defined. And after finding the domain, you can begin to find the function's range. Now we know that a radical cannot be less than 0. So we have to set this part, x minus 7, as greater or equal to 0. Because anything less than 0 gives us an error. Let's solve for x. If we solve for x, we end up with x must be greater than 7. Any value that's 7 or more is allowed and will produce an output. This represents our domain. Now what's our range? The range represents all the possible y values. So to find out what possible y values will result for x's that are 7 or greater, let's substitute 7 into our equation. Y is equal to the square root of 7 minus 7, that's 0. We end up with y is equal to 0. Let's try a very big number. Let's pretend that we substituted 1,000,000 into x. If we say 1,000,000 minus 7 square root, the y is quite large. And the bigger the x value we choose, the bigger y becomes. Therefore, our range is y is greater or equal to 0. Anything greater or equal to 0 is allowed for our range. We can write this in a formal way by saying that the domain includes all x values that are real such that x must be greater or equal to 7. And we can write our range in a formal way by saying range includes all y values that are greater or equal to 0. Let's move on to question 2. In question 2, we have the function y is equal to 3 over the square root of x minus 2. Now once again, this part needs to be greater than 0. So let's say x minus 2 must be greater or equal to 0. Solving for x, we end up with x must be greater than 2. In addition to that, this denominator can't be 0. So the square root of x minus 2 cannot equal to 0. Let's solve for x. Squaring both sides, we end up with 0 on the right and x minus 2 on the left. Bringing this over, we end up with x cannot equal to positive 2. If we were to look at both of these restrictions on a number line, you would have something like this, where that's 0, x must be greater than 2, everything going that way, but cannot equal to 2, so we put a hollow circle. And we represent that by saying domain includes all real numbers such that x must be greater than 2. Only greater than 2 because of this. Let's find out our range. Let's pick numbers that are slightly larger than 2. Let's pick 2.001. Using our calculator, 3 over the square root of 2.001 minus 2 gives us 94.86. Let's pick a number that's even smaller. We end up with 3,000. So, the closer and closer we get to 2, the y gets larger and larger. So let's pick a number that is a lot greater than 2. Let's pick the square root of, let's say, 1,000,000 minus 2, and we end up with a very, very small number that is close to 0. And the bigger the number you choose, the closer it gets to 0. So we can say that our range includes all y values, which includes all y values that are greater than 0. Now remember, there's no way that it can ever reach 0. And lastly, for question 3, we have the function y is equal to 1 minus 1 over x. The only problem is this x. X cannot equal to 0. That's our domain. And you can write it out like this. X includes all real numbers such that x cannot equal to 0. And your range, well, let's choose a number that is very, very close to 0, but not touching 0 from the left side. 1 minus 1 over negative 0.00001. We end up with a very large number. And similarly, from the right side, we end up with a very, very small number. On the contrary, if I substitute a very large number into x, 1 minus 1 over this number, I get a number that is very close to 1, but never quite reaches 1. Regardless of what I put into here, it will never reach 1. Let me show you a negative number. I get 1 point with a lot of zeros, 1. Therefore, our range are all y values that are real where y can never equal to 1. And there you have it. That is how to find the domain and range of functions. Make sure to watch part 3 for more examples.